And so this is very interesting because the agent is not rewarded based on directly on what score it gets in the game. It's rewarded on how well it fools the critic, but somehow it ends up playing a good game anyway. So this has been used for things like various things, including like Pong and Breakout, and we've been looking at StarCraft recently. Okay, so just to sum up, yeah, I think this is really a general principle that could be applied to a lot of different areas. There's been a few papers recently where people are trying to apply this to text generation. I mean, there's a lot of discussion in the blog space. People are complaining the work that's been done so far. People say doesn't quite hit the mark, but definitely there's a big scope for that. There's somehow to bring the same kind of thing into text generation. You have a generator and then you have a discriminator. This could potentially be used to improve the robustness of a lot of different AI or machine learning systems. Credit fraud detection or whatever. You could set up in this kind of adversarial way. And finally, perhaps even with modular systems. So there's sort of interest now in hierarchical evolution, hierarchical reinforcement learning. You can kind of imagine if you have a system that consists of several modules and they're all adaptive, that each module may be acting somehow as a critic for the information that it's receiving from the other modules. Okay, so I think I'll leave it there.
Hello. So let's take off some time to have a couple of questions, and then yeah. Right.
Hi, thank you for the talk. My name is Alexander. So maybe a basic question, but what I don't understand is that in the beginning you are saying that the purpose of the discriminator is to discriminate between what is generated and some sample.
Yes.
So the obvious solution to that for the generator is to recreate the sample without changing anything. That would be ideal, right? So are we just creating an encoder instead of generating something new? How do we ensure that we're not just creating multiple copies of the images which we are training on?
Good question. Well, I think, yeah, let me see. There's a couple of different issues here. So the first is that there has to be a kind of balance between the generator and the discriminator. If the discriminator is too powerful compared to the generator, then the system may break down somehow and vice versa. But so in a way, with these MNIST digits, what we really kind of observed is that it would generate realistic digits, but then the critic was trying to reject those digits, and then it had to kind of morph them so the digits actually became a bit unrealistic in response. Yeah. So, but it depends with the MNIST. It's kind of the generator maybe is the task of reproducing these images is too difficult, or the variety of images is too difficult. So it never kind of reaches that. With the CIFAR thing, whether it's because of the complexity of the images or the variety, I'm not sure, but it never quite reaches that saturation where it's producing very realistic images.
But the point is that it tries, right?
Yes.
You're creating an encoder instead of a generator of new images, right?
That's right.
My problem with this, right? Supposedly we want a generator which generates an image,
yes,
which we cannot distinguish from a real image of a real object.
Right.
But it just recreates an image which it has already been given.
Ah, no, well, yeah, oh, I see what you're saying. No, well, the thing is, every time it generates an image, the critic is then retrained and is trained to reject that image along with all the others. So it can never just recreate an image that it's created before. It always has to create new things. Yeah. So there's like this constant drive toward complexity. Yeah. Whether that's what we want, I don't know, but that's what happens. Yeah. Maybe it's a good thing.
Yeah, a question of it.
Yeah.
My background is neuroscience, not computer engineering, so it might be a bit weird.
Yeah.
But basically, for object recognition, the way that the brain is going to work for the primary visual cortex is very similar to neural networks.
Yes.
And if there was a linguist here, probably the prefrontal cortex aspect might be linked with the generator. But it doesn't start from chaos. It would start from latent phase, something else that would come maybe from the hippocampus memory, and maybe how good the image is would not be how good the classification is, but how you like it, which might be the amygdala, for example. So is it possible that instead of a zero-sum game between two players, it would be better to have more of a complex system that takes into account a bit more of the biology of the brain?
I'm not sure. Oh, I see. Yeah, how it relates to the biology of the brain, I'm not sure. But there has been some work where they people, instead of just an artist and a critic, people try to mimic maybe a community of artists or something like this. But the other thing is, I mean, these images that I showed you, they're generated with no human involvement whatsoever. But the human just comes in at the last step, and you look at 600 images and pick the ones. I look at the 600 images and pick out 21 that I like. That's sort of the human. So, but one thing we're working on now is to have a system where the human has a bit more interaction. So the system works in the background generating images, but every so often the human can go and throw away some images that they don't like. So the ones they throw away are still used as negative examples, but cannot be used as breeding material. So this would create a kind of nice balance, I think. So it's not like Pick Breeder where you're like a slave sitting there having to pick images all the time, but you do have some involvement in the process.
Okay, so your generator starts from pure chaos, not from some latent phase or already an idea of what should be expected.
Okay, that's another good question. So it does start from pure chaos, but we think that there could be a potential for transfer learning here. So if the system has evolved on one set of images and then you use that genetic material as a starting point, you can probably learn new images much faster, I would think. Yeah.
Thanks.
Is anyone else?
Hi. What is the reason that the generator cannot generate realistic enough images? It seems like there's some limitation towards complexity that it can generate.
Yes, I mean, I think that this, well, okay, that's a good question. Yeah, I mean, it's possible that, well, there's several possibilities. So it could be that this particular genetic program framework might not be powerful enough. That's possible. Another possibility is that we need to run it for longer. And again, this is where the transfer learning comes in. Like if you run it from nothing on every new set of images, probably too long to wait. But if you train it on previous images and then adapt it, maybe it could be the time complexity could be manageable. But the other thing is, yeah, I mean, it certainly does. it doesn't generate, you know, GANs generate much more realistic looking images. This doesn't really, this generates images in a different kind of style, but it's I think of it as like a constrained optimization problem. It's trying to, this system has an inbuilt, one thing about this genetic programming system is that it has selective, it's very good at having selective pressure to have shorter programs. So each new artist is trying to solve the problem of creating an image which has a low algorithmic complexity, but is good enough to fool the critic. And this is why we think that there's some similarity in a way with the abstract art of the mid-20th century, that that's maybe what those images are trying to do too. That it's trying to be low complexity, but still fooling the critic. Yeah.
Last question. Alan, can you please go back to your final slide, the use cases?
Yes.
Yeah. Improve the robustness of AI machine learning systems. Could you please elaborate a little bit more? How can we use GANs for that, or generative models for that?
Well, let's think about this. I mean, I mainly think back in terms of these sorting networks and so on. So let's suppose you're an insurance company and you're trying to detect credit card fraud. That may be one case where there's something adversarial about that even to begin with. But yeah, so you could just start with cases, genuine cases and fraudulent cases, and try to train with supervised learning. But if you introduce the critic and it could be done a couple of ways. So you could introduce the critic, and you could have a generator that's deliberately trying to create things that would be fraudulent. I don't know. This is sort of a hand-wavy argument, but I think there are many machine learning cases where this could be brought in.